again all for coming today. I'm going to start with a little bit of what Vow Software is. Vow Software is a software house which its head office is in Belgium. They have more than 25 years of expertise in quantitative risk analysis. And they started as consultants and trainings, and now they moved to being software producers, which is great. And you will remember this risk analysis book, which is a very important book in quantitative risk analysis. And now they do this risk solutions. They have three main products: ModelRisk, which will have now almost 20 years on the market, which is great. It's an excellent product. It's an add-in to Excel where you can set up Monte Carlo simulation. Then you have Tamara and Pelican, and these two are a solution. Tamara is for adding Monte Carlo simulation on top of Primavera and MS project files. And Pelican is more of an enterprise risk management solution to add risk to the whole company. So together they build an ecosystem. And we're going to talk about one of these elements today, which is ModelRisk, right? A little bit about us and our risk consulting services. So we're Fairfield, as Jameson said. We work as a very close partner to Vow Software, and we have our headquarters are in London, in England, and well, Jameson is in the States, as he said. I am in South America now, between Argentina and Ecuador. So we're very happy to take and to talk about your different needs. We have a global reach, meaning that we have a global network of consultants ensuring tailored support for our clients' needs. And for example, we're having projects so far in Mexico, we're having projects in Brazil, we're having projects in Morocco. Hopefully, we're going to have more projects in the Middle East as well, plus additional training. Right. So this is something that we do, and this is what we keep. This is what keeps us moving, right? And we have diverse industry experience talking about working before in energy, infrastructure, financial services, technology, manufacturing, etc. Right? So this is what it's the Fairfield Group. I'm the director of consulting in Fairfield Group. Very happy to be here. These are our global leader trusted customers like, I don't know, Bechtel, Atkins, Deloitte, AstraZeneca, BP, KPMG, Network Rail, National Grid, NASA, etc., etc. Right? Now, so let's go to the model of today, right? We're going to talk about insurance applications in Monte Carlo simulations. And just as a quick recap, because this is an introductory ModelRisk webinar, so please let's remind what Monte Carlo simulation is. Remember that you have a model that could be, in this case, an insurance model, right? Or any model, any mathematical model, right? An actuarial model, any mathematical model that could be built in Excel, right? You will know that this model is going to have variable A, B, and C, right? Variable A, variable B, variable C. And these variables are normally static variables, are normally one number, right? This is my interest rate. This is my investment. This is my fixed cost percentage. What's going to happen is that we are going to modify that. We're going to improve this model. And for each one of these variables, we're going to translate this variable into a probabilistic distribution. This probabilistic distribution could be one of hundreds of probabilistic distributions that you have available in ModelRisk. The moment that you add that, you add the capability, right, for each one of the variables to be profiled as a distribution, giving you ranges. When you give ranges to a variable, you give it uncertainty, which is great, right? You give it uncertainty, and you have uncertainty in the variable. What happens is that you can model better how reality works, right? So what Monte Carlo simulation is going to do is an iterative process, right? You will say it's going to be, I don't know, n equals 1,000 iterations, right? Like this. So that means that I'm going to fetch 1,000 iterations from each one of the different distributions. These iterations are going to travel here to the variable. They are going to replace the variable and be injected into the model, right? And the model is going to recalculate 1,000 times, right? This 1,000 times, it will get 1,000 results, right? These results can be, as it says there, the total cost, the NPV, the cash flow. You will see here the total premium, the total gross benefit, anything that you think in your model, right? So it will be your gross benefit, it will be the total primes, it will be the net cost, etc., etc., right? And you will have 1,000 of these, meaning that after you run the simulation, you will have the results like this. You will have 1,000 results, right? And you can generate a distribution from it. You can generate a histogram graphic from it, which is great because that's exactly what we need, right? We need for us to be able to it, right? To be able to generate this distribution. Once we have it, that means that we can generate some interpretation of the results. And that's what we're going to see today. Now, ModelRisk, that's exactly what it does. It lets you create all this system where you add uncertainty to an Excel model and you're able to simulate it. That's what you can do with ModelRisk. And you have the results and everything that I explained. Now, besides that, ModelRisk works on top of any Excel model, right? You have dozens of distributions, as I said before, 136 distributions, right? Users can easily include uncertainty and risk events, and you can see that in our YouTube videos, right? Scenarios can be easily modeled, and we're going to model one today, one scenario in which our insurance model is going to be using reinsurance or not. We can add correlations, we can add copulas, very simple. We have complete reporting capabilities, we're going to see that today as well. And on top of that, we have a portfolio optimization tool. We have integration with our Pelican and Tamara software, which is what I explained in the first portion of the webinar. We have time series modeling and fitting. We have more than 30 time series available. We have a data and results viewer, right? We have key drivers reporting, simulation, imported data management, etc. Everything comes, right, in one version, which is what we love. Now, if you're an at-risk user, if you're currently thinking or using at-risk, you will see that you can adapt the menu to the one that you know. So in ModelRisk, and you will see here, you have, and I'm going to show it to you here, you have what we call, let me see here, 1 second, in the settings, you can customize the ribbon. So you can build ribbons at-risk style, like the one that I have here, which is called at-risk style, that has only at-risk, the features in the same order that you have an at-risk, or you can create your own menu builder. So for example, if you have analysts that are going to run the Monte Carlo simulation, nothing else, perhaps you can give them 5 or 6 options instead of giving them all the options. If you're an at-risk user, you can convert models using the converter here, right? You have this convert model from at-risk in bulk. So if you have one model, you can convert the current model, and we have a video there, or you can convert it from an at-risk bulk, meaning that you will have maybe 10 or 20 models of at-risk in a folder, and once you do that, it will convert the 20 or the 20 in the folder, it will convert them automatically to 20 models, right? You have a better language change because you can change the language here and you don't have to install the package of the language. And we have only one version full of features, right? So in at-risk, you will have a lot of different versions, or 2 or 3 different versions with different prices. We have one that it's 30 to sometimes 40 or 50% of the price of at-risk, depending on the number of years and the discounts because of the volume, with one version that has everything. So now let me explain to you what this model does, right? Now, let me take you to this little model that it's really, really elegant because it's small, but you will see that it generates a lot of information and we can do a really nice demo with it, right? First of all, we have the frequency. This is an insurance model. So let me explain to you. You have a plan, what we call a collective plan, right? This plan is for a company, it's not for one person. This plan is for a company, and the company pays an individual premium. You have here. So the company, for example, here is going to be a normal distribution 2200 and 110. What does it mean? That the distribution for this is going to be like this. So you will have around 2200 people, 2000 people, right, in the company, right? Sometimes it goes to like this, but with very low probability. So more likely this is going to be here between maybe 2100, 2300, right? This is where a number of people will be. And we know how these big companies, right, they oscillate here and there. And the prime that you have, it's a normal distribution too. So you can see that like this. It's a normal distribution between 40 and 80. And most likely it's going to be between 50 and 70, the amount of money that you pay for the individual premium. So what's going to happen is that the premium income that we receive, which is here, you see here, the premium income is going to be the product, right, of these two, 42, which is the premium income, right, by month, by the 2000 people. Of course, this can vary like this, you see. It depends how many people you have and how much you're paying, right? Like this. So this is the total of people. Now, what happens next? Every month you will have frequency of event, right? This frequency of event, it's profiled with a Bose-Poisson distribution 80. What does it mean? That you have an average number of 80 claims every month, right? This 80 could go maybe from 60 to 100. Now, how is it that you get the frequency of events, right? You have a historical here, a number of events here. So this could be the historical or a benchmark or the historical of your company of different maybe branches of your company. So what I did, I took all of this historical information, and what you can do in ModelRisk is you go to model distribution fit, and this is going to generate, you see, the observations, and I click on add, and this is, remember, this is a discrete distribution because the number of times that something happens. So I added a binomial distribution. I will add a maybe where is it, a Poisson distribution, right? I have this poly, I have this scalum, right? I have many distributions, right, that I can try. Poisson uniform, negative binary, that's the one that I wanted to try. So I click in OK, and this is going to give me the best distribution that fits my data. So in this case, for example, it was a Poisson distribution. So you see that because it's in the first place according to all these criteria, and also it's going to give me the lambda of the Poisson distribution, right? It's going to be 79.5 or 80. I use 80, right? So if I click insert to worksheet, I would say, well, don't link it to data. I just need it inserted to worksheet like this, and this is going to generate that, you see? It's going to create the Poisson distribution. This is how I did that. For the premium, I did the same thing. And for the event size, the same thing, right? So I have the event size here. I have the same thing here, this distribution. Now that we have how much we make and how did I get to this distribution, let's go to the frequency. So the frequency is this Poisson distribution. It's telling me that in this month, in this particular scenario, I got 71 events, 71 claims, right? So these 71 claims are all here, you see here, and in number 71, it stops. Each one of the claims has a different size, right? This one 63, 400, etc. If the claim size is more than the deductible is 1100, you will have to deduct from it. You see, 2000 and 300, and here you have less the deductible here, like this, right? Why is that? Because I will have to pay the deductible if it's more than that, me as the user. And for the company, of course, what the company has to pay, right, is the total claims minus the deductible, right, which is here, right? So in this particular scenario, for example, the company made 84,000, which is the total prime. You see, it was very low, times 2,000 users, but they have to pay 178,000. So the gross income, of course, is negative because for this particular scenario, it was negative, right? So if I press in F9, you see that I'm fetching the information from it. I'm fetching the samples. So in this one, it's the exact opposite. You have individual premium of 55 times 2,000 people. It's going to be 120,000. I have to make payments of 32,000 like this. That means I make 86,000 like that. And what I can do is I can continue getting that information. So you will see that sometimes the results are very positive, 90,000, for example. And sometimes, let me make it here. Let's see what happens. If I can make it, for example, here, the results are going to be very negative, right? So in this case, we are not allowing reinsurance yet. I'm not going to explain this yet because I want to show what else you can do. So all this information that you have here, they are inputs, right? The premium, the frequency, all the distributions are inputs. We have some parameters like the deductible, right? And for the insurance company, we have some outputs like the premium income, what is it, what we receive, our compensation payments, and the gross income before reinsurance. Finally, the net margin. Every one of them has what we call a BOS output, meaning that it's a net margin. So this is a basic and very simple Excel model that we enhance by using ModelRisk. So I'm going to run this, right, 1,000 times. You see, 1,000 times. I'm going to run 1,000 scenarios. And what's going to happen, and you will see here, right, is that, for example, if I click in the gross, in the premium income like this, you see that I get between 55 and 206,000. That's what I get, right? In terms of the money that I get. What I can take a look is, well, how much do I compensate in payments, right? So it's okay, but sometimes it's not. You see, let me eliminate this one. So in payments, I can pay from 6,000. You see the mean is a little bit tricky here because it says it's 84,000, but my maximum is going to be 1 million, right? It's here. Now, if I increase the number of iterations, what's going to happen is that I will be sampling more extreme values. And that's why you have, or you can increase the number of iterations, because this is going to increase the probabilities for you getting samples all this way, right? Where the risk is, which is here, right? What else you have? You have the net margin. So the net margin, of course, is going to have a bias to the left. Why is that? Because sometimes when you have the, remember, the 1.3 million, you will have to pay this. So this will come between minus 1 million, which is in a very bad place, and the 160,000, right? So majority of the time you're going to be here, right? But if there's a bad event like this one here, you could lose everything, right? And that's why you get reinsurance. So when you get reinsurance, let me tell you how it works here. You see, it says apply reinsurance 0. But if I apply reinsurance here with a 1, this is what happens. I will pay for the reinsurance premium. So I pay for the reinsurance premium, which is 40,000. I always pay for that. But my deductible is 100. So that means that everything that is more than 100, this is going to the reinsurance company, right? So of course, how do they make money? Because I pay them 40,000, but all the tail that I have, remember this left tail is for them, right? So that's how they make money, right? So if I go here like this, for example, let's take a look here. I made 102,000. I have to pay 189 in compensation, right? But on top of that, I had to pay the reinsurance premium, right? Now what happened? What happens is that if I have reinsurance premium, everything that is on top of 100, this is going to be a recovery for me. So at the end, instead of losing 80,000, I'm going to lose 37 because I recover this 81. I pay both the 40, but I recover this 81 like that. So let me do another one here. You see, in this case, I get 135, I have to pay 35, it's going to be 99, I pay the 40 for the reinsurance, it didn't have to be used, so my net margin is less. So you have all these scenarios, right? And at some point, you will see that every time that I use the reinsurance, my losses really cut, right? They are really cut, which is great. That's exactly what I wanted, right? That my losses are going to be cut. So how can I do, right, in a regular model? What you will have to do, you will have to run the model that I ran before with no reinsurance, remember? Take a look to it, and now take a look to the model with reinsurance. And with reinsurance, of course, I generated this logic here, 0 and 1. Right? But now we have to do what we call scenarios. So what we were going to do here, you see, you have scenarios. 0 is no reinsurance and 1 is reinsurance. So how do you apply that? Now that you have this and you know that exactly what you want, you see that the good thing about modeling here in Excel is that this model maybe is the model that you already have in your computer. As this is the model that you have in your computer, it's already answering things. Perhaps when you add Monte Carlo simulation, it's going to add more things and answer more things. But in this case, it really answered one thing, which is my net margin. And my net margin, remember, we'll show it again, right? Let me show it here with results. My net margin is negative and it goes like this, right? So I have to take a look to it and see what I can do for it. So what I will do, I will add what I call a sim table. I'll do a sim table here doing like this. It's going to be called Bose sim table like this. It's going to be 0 and 1 like this. 0 and 1, L6 and 7. L7 like this. Right? What this is going to do is going to add two scenarios. Scenario number 1 is going to be no reinsurance. Scenario number 2 is going to be reinsurance. Right? That's what we call scenario modeling. And in the settings, what I'm going to do, I'm going to run two scenarios, two simulations, which was already there. And I'm going to add names to the simulation, which are no reinsurance, I'm sorry, here, no reinsurance and reinsurance, like this. Right? This is great. So the moment that you have that, that means that you're going to run and you're going to leverage the same model that you have now, and you're going to run two scenarios on top of that. Right? So what I will do, well, first of all, I will save it. This is Excel, so I will save it. And then I will click on Start. And what this will do, you see, it's a simulation 1 of 2 and 2 of 2, right? And what's going to happen is that I can do, you see here, now I have two simulations, no reinsurance and reinsurance. So what I can do is I can click here, the no reinsurance, see, well, what's going to be my premium income, like this. And what is the premium income under reinsurance? It's almost the same, right? It didn't change because it doesn't have anything to do. This is the reinsurance calculation comes very, very late in the process. So it shouldn't be different here. But if you go here to the gross income before reinsurance, this is something that's going to change a little bit, right? And when we see the difference is when we take a look here to the net margin. Take a look here. So in the net margin, you see that the one in blue, right? Let me show you the legends. I see the net margin with reinsurance is going to be here. It's going to stop here in 100,000 as we expected, right? And the net margin in red is the one without reinsurance. So what is it that happened here? That we sold this tail, right? Sold the tail to the reinsurance company. That means that you don't have this tail anymore. You don't have this availability for these scenarios anymore. This is not going to happen. If you want, you can take a look here. You see, you have the mean is going to be minus 740,000 and a max of 190. But if you go, and this is the net margin of the no reinsurance, right? This one here. But if you take a look to the one with reinsurance, take a look at this. you have minus 65,000 and a maximum of 134. So of course, what is the cost of all of this? That if you take a look to the previous one, my potential maximum was 190,000. It's a lot of money, but the downside was very high, minus 800, let's say. In this case, I cut my losses to minus 65, and of course, this was a big cut, but I cut my premium. Why is that? Because I have to pay 40,000 every month. Right. The good thing about this, and you will see that in ModelRisk, you can change the chart type. You can see it like this. Now you can see it better, the tail here. Or I don't want to show the sliders or the legends. So you can see it's very simple to see which one. You see, remember that the reinsurance is the red one, right? And I'm sorry, the blue one, and the no reinsurance is the red one that has the tail. You see? I'm sorry, let me make it red here. You see? Is the one that has the tail. This other one, as you can see there, cut the losses, cut all of this, which is great. That's exactly what we wanted, to cut the losses. So this is one thing that you can do with ModelRisk. You see that in more or less 25 minutes, we were able to explain one of these models. What is it that you can do? All the things that you can do, you have this tornado chart. So let me generate one. It's a tornado chart here, right? And this is going to tell you what are the most important tornado charts for the no reinsurance and the reinsurance scenarios, like this, you see? And what I can do in my tornado chart, I can say, well, I want to see it in 100%. So my frequency is the variable that takes 96% of the risk under the reinsurance model. Under the no reinsurance, it's also the frequency. So if you want to make a dent, if you want to modify something, right, that it's going to be small, and you want this impact to be big, right, you have to modify the frequency. So this is going to tell you, well, if you want to change the model, let's change the frequency. Imagine. So if we change the frequency to 70, right, we can run the model again and see what happens. If we can run it to 70, 60, etc. Even more, so you can do a scenario that says, what if my average is 80, 60, 50, etc. Right? How is it that you decrease the number of claims that you have? Well, perhaps you have a healthier portfolio, or maybe you want to include that. You have to do you can do all this analysis with these scenarios that I just explained, right? Like this. So my idea and my recommendation is for you to run it like that. Now, if you want, remember what I said before, if you want to run 5,000 iterations because you want to see the extreme values, you can do it from here, right? Like that, you see it's running 5,000. And with this, I will open the floor to questions. I know that, I mean, I didn't want to have a big model here, but something that is very, very straightforward. Right? Let me see if I can change the types like this. And you see what happens is that here, and this is exactly what I wanted to do, you see, is that in the gross margin, you have minus 896. So it's very important for you to be able to increase the number of iterations, right? So you get to the extreme values. Otherwise, you're not getting to the extreme values, right? And perhaps you will underestimate the risk, which is a great thing to do. Other things that you can do, for example, in the results, you can generate, as we're talking insurance, you can go to the data list here, and you will be able to see all the 5,000 iterations, right? For all the variables, you have them here, right? In case you need it for regulatory purposes here. Or you can see the statistics. If you have actuaries in your team, I imagine that you do, it's an insurance model, right? So you can have all the statistical, descriptive statistical, like the percentile, skewness, standard deviation, the variance, mean, maximum, etc. All the statistics without and with reinsurance. You see here, you have the two simulations here, no reinsurance and reinsurance, which is great, right? You have all this information available for you, right? In case you need to include it. Now, what else you can do? For example, I can create a new graphic here, and I say, you know, I want this tornado, I want this histogram, right? Let me see this, which was the histogram? I think it was the histogram, right? This one here. So I can say, okay, I want this histogram to appear. That's great. So what I can do, I can go to this one that reads link chart, create a new link chart like this, and this is going to add this chart to my Excel graph, to my Excel sheet automatically. So every time that I run the model, this is going to be updated automatically, which is great because you don't need to do this manually. Normally, that's what we do, right? We take the picture, run the model, go to PowerPoint, paste it. In this case, you don't need to do that. Right. Finally, and this is something for you to try, you can create here in Insert, you can create, let me see here, in Home, you can create reports as well. So you can copy the chart, you can create a result, a report, you can export to XML, etc., etc. So the main idea, and with this I will finish, is that as a recommendation, as always, try to use it as much as you can and try to practice as much as you can by modifying small models like this. Take a look to this model here. Imagine without distribution, this model would be like 20 cells in Excel, and it wouldn't be as rich if you don't have ModelRisk to play with. Now that we have ModelRisk to play with, take a look to all the things that we can do. So adding Monte Carlo simulation on top of your Excel models really pays out. This is going to change the way you model, and this is going to change the way that on how you do things.